Hello everyone, welcome to this session. In this session, we will do the assembling of all those parts we created in the previous sessions of the screw jack assembly. We will quickly see this assembly drawing. Uh, I hope you see this schematic. This is the half section and front view of the assembly of this screw jack, where the number one is body. Inside on the top of this body a nut is fitted, and then the third one is a screw spindle, which is uh, fixed onto this, inserted into this a nut. And then a screw on the top of the screw spindle there is a cup over here, which will be going to come, the top surface is going to come under the contact of the heavier object. And this cup is fixed by washer and the countersunk screw to the top face of this screw spindle. And there is a hole inside in the screw spindle where we can insert the tommy bar and give the torque to the whole spindle, so that screw spindle moves as the heavier object moves up and down. And once you fix it to the certain distance, you can remove this tommy bar. And this is the idea of this overall screw jack assembly. uh, in the beginning of this examination, and during this you might have by with the help of part drawings, you will create this manually using your drawing instruments in a A4 sketchbook. Then based on that, uh, you will sequence the models into the assembly mode. uh, Here only part drawing will be given in the examination, no assembly drawing. Assembly drawing you have to memorize and draw it by the help of part drawings. So once the part models are done, you are going to use assembly module. Assembly module is very simple, where you need not you are not creating any entities there. Only thing, you are placing them and aligning them into the order which is given into this assembly. Okay, we will keep this figure as a reference for the sake of this session, and then we will quickly go to the assembly model of this solid edge and try to build the assembly of this screw jack. Here I have already saved the models which are done in previous sessions. There are 7 parts. We have to align it using assembly model. Okay, start your solid edge screen, and we have used solid part to create the models. For aligning them into the assembly form, we are using assembly interface. Click on this assembly interface. It is also similar to the part creation. Blue screen 3D environment will appear, and main menu is very much similar to the main menu you have seen from your solid part or drawing. It is the same icon. New creation, new assembly creation. If it is already done, you can open it, you can save it, and you can view the assembly into these wireframe and shaded visual models, and you can turn the assembly into the waves. Okay, apart from this, that leftmost um, uh, icons you can see here, this is assembly pathfinder, just similar to your part specification tree. Whenever the assembly file is opened, you can see here 3 default planes will come under assembly 1, and the file extension is ASM1. And along with that, this is part library, where uh, it will show you the path where your parts are there. Otherwise, you can set here in your hard disk. You might have saved your as I have saved my all parts in the desktop in one folder. I have to search it, and I have to double click on it, and all these parts and previews will be seen in this parts library. Okay, you have to all icons here are gray. I hope you can see here all are gray in color because no part is added here. How to add the part here? I will show you now. Just click on this. Once you set your part library option here, and if you choose your folder, and all your parts are visible here with these icons. Just first I am fixing my calling my body. How to call this? Just click on it, drag it, and drop it onto the screen. So I think this is clear. This part has come and exactly set. Check this with different views. In assembly also you should get the same position here. Why I used particular planes you can understand, because here in your drawing the assembly should look something like this. Tommy bar should come in this position, so I used those planes to uh, create the models. In assembly you need not spend much time in assembly, so that automatically the parts you should not struggle for positioning it. So mm, the first part has come here, and now all the icons features are become active. Now you see this is assemble icon. When the part is come another part we require, then we can switch on this assemble command. Or whenever any part is come, it is ready to assemble. You can just pick the surfaces, align the axes, so it will be moved on to the required location. And these icons, library and fasteners, these are not required for us, because in industry they will use for these fasteners of standard libraries they create, and they take it from there only. As we have created our own fasteners, no need of these advanced commands. And pattern we are using it rarely. Whenever one nut or one bolt, there are 10 bolts, we can use pattern here also in the assembly mode. So we will call the second part here, as the second part is nut. And you see it is you can observe here it is transparent. That means it is ready to assemble. Okay, no need to click on this icon, as it is transparent. You can use it for assembly. Just you can pick this bottom surface, it will be aligned with the top of this body, and just it has come here. And you should align the center of this cylinder to the center of this body. Now you see that it is aligned. And after once it is aligned with this body, you just select to go of the out of this assemble tool. Now you can see that is perfectly fit into the part. Okay, now you just keep it on front view. Okay, now quickly call the second third part, which is screw spindle. It has to go with aligned with this nut. Now it has randomly, it's don't worry about this. Now you just drag it, it is still transparent, just drag it upside. In assembly drawing he has not mentioned any distance here, so just move it with an approximation. Keep it. And in assembly drawing the hole should be horizontal. Now you what you do is you just right click on this part, and show hide component, go to show hide component, show its reference planes. Okay, now I have in the model creation I have hided these planes. Now you can see I have shown these planes. I want to align this, go to assemble command, take this plane and then align with this plane. Now you check your front view, the hole is exactly horizontal. Okay, by this use of this command, show hide commands, and using these planes you can align, and it will help the assembly, taking the assembly drawing view as per the um, in the question paper mentioned. It will be helpful. Okay, now call the next part, drag it. The next part is fourth part, that is cup. Just drag it and drop it onto the screen, and select this bottom edge, bottom face, sorry, and select the top face of this spindle. Now select this cylindrical surface, select this cylindrical surface of the spindle, then exactly it has set. Now check the front view. Still there is alignment is required because this slot is exactly perpendicular to your view. When you see here, the slot is perpendicular to your view. Here it is a little bit turned. Don't worry about that. Go to select tool, escape from this assemble command. Now right click on this cup and show hide. Go to show hide, show these reference planes, and align any one of these planes with this assembly plane. Now you see the front view. Now it looks fine, I think. Okay, so after doing again you hide these planes, and this will give rise to confusion. So it should be very clean, part should look okay apart from this assembly planes. Okay, now the fifth part is washer. You can hide these parts here to feel comfortable. Go to this assembly pathfinder. Now you see I have inserted the four parts, you can see here, along with assembly planes. You can see here, and now I will hide. You can hide from here. uh, you can hide from a specification tree. You can select, hide this, so it will be easy, convenient to operate here. The washer will come and sit here, so I just hided the other parts, otherwise rotating will be easy. Fifth part is washer. I will call by sequence. Take this bottom surface, select this, and mate this to top of this cup, and then now select the cylindrical surface, align it to the cup hole. Now you can see the top view. It has perfectly installed onto the inside the cup. Okay. Now immediately you can hide these planes. If you feel uncomfortable, you can only turn this comfortably and go to part library and take this screw and take the top surface, select the top surface, select the top surface of the washer, and then select this cylindrical face of screw and select this washer inside cylinder. Now you see, okay, now they have perfectly, it is screw is inside the washer. Okay, Now you go to Assembly Pathfinder and just show your all parts by right clicking on it and show it. Okay, now keep it on front view. Okay, and this looks fine. And now you bring this your Tommy bar and select this in a spindle cylindrical surface and zoom it. Just rotate it. It has to go inside this hole. Select this and now fit it. Now keep it on front view and fit it. Now just drag this and you see the assembly drawing here. There is a it is almost touching here, and there is no particular dimensions given here. uh, okay, now it is fine. Okay, now your model is all the parts are aligned and mated, and sequentially they are placed inside this assembly. Then once this is over, you just uh, onto the screen, you check the top view here, front view here, like this, right view, and whichever view you want to position it, and save it. As save command, use save, and there are no attributes required. Just in your desktop, what is the folder you have already created. Here I will save it as screwjack .asm is the file extension of this assembly file. Save it. Now at the top of this file you can see here screwjack.asm file has been saved. You can check in your folder, desktop, screwjack assembly. Here the screwjack assembly, this icon is different than this .par. These are .par files. This is .asm file. Okay, it should be saved before you create the assembly drawing. Okay, now once this assembly is saved, just go to file. You have to go to the drawing. You have to say generate the drawings with the use of this assembly, and give a print. After that you can give the print to your examiner. And now I will go to the file and go to create drawing option is there. You can see here create drawing and just say okay. You will be getting into the drawing mode. Say next here. Don't worry about that. Here diametric, you can choose the views you want, or else here one custom icon is there. You can see here with the common views. You can turn it up here, whichever the way you want to it will be generated onto the your sheet. You can keep it and close it, and next finish it. And one layout will be in red border. Just click on this sheet. Whatever is the sheet, don't worry about it. It is the random sheet. You have to set it in A4 sheet, because in colleges, in academic institutions, we use A4 sheets only to view these drawings. So here sheet 1 will be there. You just right click on this. I think you are familiar with this option while doing the drawing. Sheet setup, change it to A4 sheet and remove this layout background. We don't want it. Planar sheet is sufficient. Now try to fit this view into this. We have to scale it down. It is 1:1 by default. It has generated. Here you see, by the moment I click on this, uh, just move your cursor until you get this red border. At that time you click on this. These icons will be there. Just here you scales are there. You try to reduce this. In examination he will ask you more than if one view is required, you reduce it to 1:2. If top view is asked or side view is asked, You further reduce this uh, by 1 is to 5, take 1 is to 5, and then for to generate this top view, you go to here, principal view, one option is there. Click on this icon, click the principal view, and if you take the cursor, it will give you the top view. As we are doing it in first angle projection, this sheet is set for first angle projection, and if you go to here, it will give you the left side of the right side of the view, side view, and then uh, for to uh, give the balloon callouts, here one option is there, part list. You select on this, and then if you give, if you want balloon callouts onto the view you want, you just activate this, and material schedule you want to be in the drawing sheet, you just activate this part list and click on the icon view in which you want the balloon callouts to be generated. Just click on this and finish it. You will get the material schedule. This attributes, what we were doing in the model creation. I initial in the beginning, before starting the model, I used to give the attributes in the while saving the file, name of the body and material. It will take from those attributes and creates the material schedule automatically. You can change these by going to right clicking and properties. You can set into ANSI standard, or change your font, or change your font size. You can do that. And then here the balloon callouts, here one option is there, smart select tool, smart select. You select this, select one balloon callout and say okay. All balloon callouts are selected. Make them break line, and then you choose this item count, switch off it. I need only balloon callout, and click on it and move inside the sheet layout. Okay, you can do that, and once they are arranged, you can change the color also here. So this is it. Once this everything is views asked in the exams are finished, you can save this as a drafting file. Go to file, save as screwjack.dft is the file extension. You save it, and you can after this you can go to your folder, make sure that all parts related to this assembly are there, and assembly file 3D assembly is there, and screwjack drawing has been, just now I have saved it as a .dft file. This is going for the print. You can give this, you can show it to your professor, or you can show it to your examiner, then 3D will be there. So this, I hope this is clear. This is for one assembly. This drawing, assembly drawing comes for 50 marks. Entire procedure from model creation to assembly creation, assembly drawing generation, you have to do this in examination or in IA internal tests for your purpose. I hope this video will give you an idea how to create, how to practice using SolidEdge software. Okay, in the next session, we will take such 4 to 5 assemblies are there for your curriculum, and we will take them in next session. Okay.